All right, good morning, everybody. Thank you so much for attending today. My name is Sana, if you haven't had the pleasure, and from Gantco, we're going to be going through a sales team presentation today. So there is some overlay with this presentation and the one that we did on Wednesday, just because if there are some sales team members here that weren't there, I want some critical parts and critical information to be actually crossed over and shared with the sales team as well. But the overall style of this presentation will be in regards to costing, in regards to budgeting, and in regards to preliminary designs when you guys are initially putting together your PV work, whether it's PV layouts or you're trying to price for a client. The main objective of this one and how it differs from the other one is to try and fix the common issues that we find with sales teams not having just a basic understanding of structures and how it works, which can sometimes lead to clients being unhappy because they find out very soon after they were promised a certain size system that it may have to be reduced because of certain critical factors. So today we're going to be going through them critical factors and why and how helping you understand them a bit better may help you give realistic expectations to your clients in times where it can be quite serious and quite critical. So without further ado, I'm going to go into, firstly, the webinars we've done so far is the project management team on Wednesday last week, and today we're going through the sales team. I also want to share that it's especially important for PMs or anyone that does site audits to join the how to complete a site inspection and measure, which is next Wednesday at 2 p.m. And lastly, probably one of the most important ones is the secrets behind using roof sheet clamps. And then that happens next Friday at 11 a.m. same time as today. So suitable for all members of the industry, but definitely more tailored to people that are installing or people that are project managing. Let's get straight into it. So overview of what we're going to go through today. So how do you close? Like what kind of things do you talk about when you close? Some critical information in regards to what we do in our processes and how that should be viewed from a salesperson. I understand that no one here is engineers or structural engineers. I'm not expecting anyone to have the firm structural engineering understanding, but we're going to be going into just things that would be good for you to know as background information and to be a better person in the industry, in the solar industry. Lastly, we'll go through sales flow cycles, what we would consider an ideal cycle, what we can do to help. And then lastly, some project examples. Project examples are very similar to the ones that we went through on Wednesday, but feel free to submit any questions at the end. I have some commonly asked questions by sales team members. In that time, take the time to write down your own questions as well. So let's get straight into it. So about Gantco, what do we do? So we're a structural engineering firm who's predominantly serviced the commercial solar industry for the last, I would say, close to a decade. We do other works in regards to the steel fabrications, playgrounds, bridge designs, and other complex steel designs. But our main focus is roofing ground-mounted solar. And in the last 1 or 2 years, we've been doing something called physical roof sheet testing as well. And that kind of ties into that last presentation, that roof sheet clamp, the secrets roof sheet clamps. So going to sales, how do you close, right? You guide the clients through the process. You ensure your clients are doing everything to safeguard their properties and understand some of the details of the structural assessment and how we ensure the structural integrity and understand why we can't completely fill up the panel. So they're the main goals of this conversation. I'm sure when you guys are closing, you're definitely predominantly talking about the output of energy, the savings that clients are going to get. But what I would always like to encourage, and I have encouraged in the past, and it has worked quite well for some sales teams, is to bring up the conversation of the structure and its integrity earlier on in the process to the client. Letting them know that it is a critical factor that needs to be considered, just as much as making sure they get enough energy output, will then make it a bit more understandable if something was to go, something more critical in that building isn't as strong as we'd all hoped. So the reason I say how do you close, I'm sure it is definitely an energy output, but start weaving these conversations a bit earlier. And I'm sure for your own client frustration and relationship, it'll be actually a lot better. My background is in sales as well as engineering. So I'm quite familiar with sales techniques and closes. And I know that any kind of unexpected things that can come up in the earlier part of the conversation, I'm not saying it will come up, but if it does come up, makes it a whole lot easier to go through the process and actually rectify the issue. And even if it means variations or anything like that, when the conversation is brought up earlier, that conversation can be had easier as well. So going to our assessment process. So understanding that what we do, so I would say these percentages aren't exactly accurate, but in a rough estimate, 50% of what we do is the structure itself, which is the structural capacity of the steel and timber members of the building, whether they can hold the extra weight of the building. And then lastly, the other two components are the fixing assessment, which is effectively how much the connection between the roof clamp and the roof sheet, the strength of that connection, because it is quite a small connection, and that's the critical factor of whether your panel is dislodged. And lastly, we do a slight array frame check to ensure that array frame is suitable for your building, for that height and for that wind region and so on and so forth. There is a few differences between clamps and penetration solutions. We'll go through a bit more of that in detail later on. So firstly, and most commonly known, is dead load analysis. So the weight of the panels going onto the roof. Now, we have seen cases in the past where buildings have been designed to the absolute limit, and when you are adding this additional weight of array frame and panels, you start seeing cracking or you start seeing deflection inside the structure. It can be quite a critical thing and a very expensive procedure if it actually does happen. So we want to eliminate the potential of dead load deflections happening, which is effectively meaning the weight of the panels and the weight of the system being too high. So that's one part of our assessment. What I said last slide is about 50% of the weight of the assessment. But the common assumptions around it, the panels are light and the weight of the panels is all good because people have been installing for 20 years. But in many cases, the buildings are designed to the limit and it's not necessarily all right. But the predominant cause is probably going to be wind, and we'll go through that in a couple of slides. But understanding what structural components hold this dead weight is what we're going to be going through next. So there's a few types of roofs you can see here. We have, you have basic roof systems are kind of either going to be steel or timber. Both of them are kind of made and assessed in the same way, but obviously the strengths are very different, which means that steel structures are usually quite large, and timber structures could be like residential structures or home structures. And when we're looking at steel structures, the main components are these major elements, which are called rafters, and the minor elements that connect above them together are called purlins. Now, purlins are your direct support to the roof sheet. So you have roof sheet on the top, then you have the initial support, which is purlins, then you have the major support, which is rafters. And then these rafters take the loads down to the columns and into the slab foundation. So effectively, it's a whole complete system. It's all locked and tied in together. When we do our assessment, although we understand that the foundation is overall where the forces will be ending, we believe that this section of the roof is the most critical section of the roof, the rafters and the purlins. So when we do our assessment, we look at the deflections of the purlins, we look at the deflections of the rafters, and we see how critical is the additional panels onto this upper structural system. Now in timber, it's more or less the same thing, but instead of calling them purlins, you call them timber battens, and they're quite small in the scheme of construction members. But usually because of their small size, they're spaced closer together, and that gives them quite a high strength as well. Usually when I say this as a rule of thumb, timber is usually better. The reason is for two reasons. Firstly, because they're quite spaced together and rigid as a system. And secondly, because when you're fixing to timber, you can get a screw, a certain depth into the timber, and that fixing assessment's, quite high as well. Basic layout, when you're looking at a bird's eye view, looks like this. If this is your kind of basic standard warehouse structure, similar to this looking one here, you see that there's a ridge line down the middle, and then you have your rafter elements going up and down the page, and they have a certain spacing. And then you have the purlins going left to right on the page, and they have a certain spacing as well. Now, conversation we had on Wednesday that it's too hard to say that there is an actual limit. There is no limit. The bigger the span of these purlins, the longer they have to effectively span between rafters, is dependent on the size of the purlin. So if you have a really long span, you can have a really big purlin. If you have a very small span, you can have a very small purlin. So there is no real rule of thumb, but we're going to go into some warning signs you can take into account in the initial sales process, just to be able to understand, hey, this one may have concerns. I might need to start having this conversation a bit earlier than I usually would because of these elements, effectively. Now, going into the structural warnings. So these are the ones that we're saying, things that you can consider prior to effectively pricing, or if you see a few things, maybe make it a part of your sales cycle to say, hey, I need to introduce the structural talk because, for example, age of the structure, whether it's new or old, both have advantages and disadvantages. But if it's a new building, then there's a lot of complexity in the actual purlin structure and the build itself. We'll go on to some examples in the project case on why that is the case, but the more important part as well is quite an old building. So if you're pricing quite an old building, understand there might be an element of even as simple as something like rust, right? Rust can really affect the structural integrity of the members. So it's really important that, whether you have a brand new building, which is, it's the red flag for yourself, and you say, hey, I've got a brand new building. I don't remember what Sana said in that presentation, but all I remember is that he said, if it's a new building, there's a bit of an orange flag about that. And I might have to start this conversation now. So when it gets to the engineers, there isn't that new and unexpected thing, because a lot of people think, hey, I've got a new building. It's going to work because it's brand new. That's not necessarily the case. And same thing about old building. You get an old building, you say, I don't remember what that guy said about, in the whole presentation, but I remember he said, when it's an old building, I've got to take these things and have these conversations early. Now, in regards to purlins, although I did say it doesn't matter about the length in regards to, it could be a bigger purlin size, a rule of thumb, in my opinion, is always 6 meter purlin span. So if you can see from the roof, like from the bird's eye, that's quite a big building, and the rafters, which is the main major elements, are spacing more than 6 meters, means that purlin's it's got to go a long way before it gets to its next support. At that length, it has to be quite a big type of purlin to be able to withstand the deflections. Now, if it's more than 6 meters, major red flags, and then you start saying, hey, look, do you say to your client, look, we can do it, but I'm not too sure if your building's been designed for solar, so that's going to be a consideration that engineers will have to look at. Having that conversation will help your sales floor, I guarantee, a lot more. And lastly, the height of the structure. I want to bring this in because it takes both things into account. Firstly, the height of the structure in regards to the strength of the building as well, but mainly for the wind pressure. And we're going to that in the next one as well. If you've got a very, very, very tall building, this is a kind of like a little diagram I found that kind of explains, wind pressure according to height, or I should say wind speed according to height. And you would know it, right? If you're in a tall building or a balcony, obviously there's a lot more wind than when you're down on the floor. So in the same respect, if you've got solar panels higher on top of a skyscraper, or even a 10-story building, or even a 5-story building, it's going to be very different to your residential style or your standard 4-meter warehouse height. So take into account, and obviously there is a maximum kind of wind speed at one point, but it does increase significantly in the initial 20 or so meters. And this is why a lot of your fixing assessments from the general certificates will allow up to 20 meters, because it has a certain amount of wind pressure up to 20 meters. But then after that point, you need to get site-specific assessments, because it becomes quite, you need a site-specific assessment to actually see what the wind's doing in that specific area. Moving on, I hope the warnings were a bit clear. Let's look at the wind analysis. So wind on a building, a lot of misconception around this in the industry. Wind is actually, in my opinion, and I would say in Gantco's opinion, the most critical factor in the assessment. Wind is being held back by usually either a screw between the array frame and the roof structure, or a clamp between the array frame and the roof structure, both of which are very small elements. So it really doesn't matter how good and how magnificent your structure is, if you've got a really bad roof sheet, or you can't penetrate enough into the structure, then that's going to be the most critical part of the assessment. Whether them panels will dislodge off the roof is going to be the most critical part, and that's what happens in a lot of the cases. Understanding how wind works. As wind comes into a particular building, it hits different directions. So the best example I can use is this. If you had wind coming in on zone 3 and then zone 4, then this edge zone this wall is going to be affected by the wind. That wind can't really go anywhere, so it either goes to the left, to the right, or up. And as well as that, you can have direct wind onto that ceiling, that roof space as well. This whole row becomes the edge wind pressure zone, and it's quite significant compared to this little zone 1 that you see. And in the same case, you have the same thing on zone 3. The wind wants to go up. Now you see this corner is being affected by 2 directional wind. And that's why this corner usually is a much higher pressure than the internal zone. And that's why you see in some of our certificates that sometimes these corner areas are marked out as, other, additional rails are required, or, they might be excluded altogether. So understanding that's where this comes from. We'll go into a bit more on what the shapes look like in the next slide. But it is a very important component. The reason I bring this up, sales team, is because sometimes you have installations and it's only on one side of the building. Let's say this quarter here, but there's still 30 or so panels on these corner zones. If you really just move them over into this internal zone, you'd be all sweet. But because we don't have even a basic understanding of how this wind pressure works, sometimes we find that the panels are just initially proposed in the wrong spot. And then on the other end, if you're filling up the entire roof, understand that, hey, zone 1 may be okay. Zone 2 is probably going to be critical as well, but probably okay. But then corner zones, hey, maybe I shouldn't put panels there. Maybe I shouldn't tell my clients that, we can have these extra, the combined maybe 30 panels, 10 in each spot or 5 in each spot, right? Now, I don't want to go into the mathematics of the wind calculation. It is quite a complex thing. The reason I bring this up is to let you know that there is too many variables that come into play when we're assessing wind. It's not just one thing, and each of these variables, they definitely hold a different amount of weight in the formula. So some variables may be quite a small number or quite a small reduction in factor, but other variables hold more weight. And the reason I bring this up is if you have two sites, the exact same building, one is in Queensland, one is in Victoria. The one in Queensland is in an open space, and the one in Victoria is shielded by other buildings. You're going to get significant different results, but they're the exact same structure. Or it might sound like it's quite straightforward to you guys, but you'd be surprised how many people don't necessarily believe us or understand that. And the last thing is the design wind pressures. Design wind pressures, that it does matter if it's your flush or tilt or the actual shape factors you're building itself. I want to go through a few of them now. The example that we saw on the last page was a roof which is greater than 10 degrees pitch, where the ridge line becomes a critical area of wind as well. In that same kind of shape, same gable style standard roof looking shape, under 10 degrees, you can see that the ridge is no longer a critical factor. So you have your corner zones, you have your edge zone, which is the hashed one. Then you have the intermediate zone, which is the gray shaded area, and lastly the internal zone. Now the internal zone again is the safest and least amount affected by wind. It's still obviously affected by wind, but just less than the edge. And we understand now the edge is because it's got direct wind going to that wall, and the corners it's got true directional wind going into that corner. And then if you have flat roofs, if it's smaller than 10 degrees, you have the same kind of corner setup. And if it's greater than 10 degrees, you have pretty much a greater corner or a greater edge zone, which holds a bit more merit in the assessment. Again, same reason I said before. Understanding this now, you say, hey, I've got a greater than 10 degree roof here, and it's pitched on both sides. Hey, maybe I'm going to have problems installing along the center of the ridge structure as well. And I'm quite sure everyone's thinking now, how do you calculate them edges? And that's what I'm going to go into next. So calculating the edge zone is a very, very simple formula. It's defined by the standards as it's a dimension-based formula, which effectively means if you have the average building height, the building breadth, and the building depth, you can actually get the result of what the A value is. And the A value is the distance from the edge to the internal zone, that distance there, that whole distance. Now, A divided by 2 is that half distance between the edge and the intermediate there. But the point is that we've created this sheet for a few clients now, and it was suggested to us from one of our clients to say, hey, my sales guys are, they want a bit more information on what can be critical. So we've made this sheet that effectively tells them, look, put the average height here, put the breadth, put the depth, and then they can see what their critical area is, which in this case is 3 meters from the edge around the whole building is going to be critical. Now, when you're designing PVs, then this company would be saying, look, we would ideally want to get, 120 kilowatts, but your edge zones and your wind zones are 3 meters from all edges, which can bring it down to 100. Now they not only do they understand the limitations of the installation, but they trust you to be somewhat of an expert, because Joe and Blow and whoever else didn't say anything about edge zones, didn't say anything about wind, didn't even know what it meant to care about their structure or the structures in the integrity of the structure. So it's a really good tool as a place of intellect, as a place of showing them as an intellect closure. To say, look, we know our stuff. We are the best in what we do, and we take all things into consideration, including the structural components, and we're just having a chat about it. It's we'll give it to the structure guys to actually do the assessment. For now, we're just having a chat about it. Now, where this doesn't cost anything, it's actually it's a blessing in disguise for us, because when you guys do that, it makes it less headaches for us as well. So it is a very free tool that anyone can use and you can request, and it's just a very basic sheet. You just need 3 dimensions to put in there, and you have a far greater understanding of the critical areas of your roof. The only thing that comes from that is you have to understand whether it's a pitched roof greater than 10 or less than 10 degrees, and also if it's a flat roof. And then you can make your considerations and start having your conversations around which one of these it abides by. Roof sheet types. Now, we did go through this. The reason I bring this up is with the sales team as well, is because it should put some reassurance in your mind, as well as should raise some red flags for you. So going through it in somewhat more abbreviated manner, you have two roof sheets made by the same manufacturer. One is Fielder's King Clip 700, the other one's a Fielder's Hick Clip. Now, how these roof sheets are actually installed on site is that they have these internal clips. These internal clips, a roof plumber would come through and install these internal clips into the structure, whether it be timber or steel. They would screw these internal clips down, and then they get this roof sheet and they pop it on top and they press it down, and it goes and it kind of locks into this clip space. In the same way here, they've screwed these little things down, and then they've put this roof sheet interlocked it. Now, the difference between these capacities and what we're talking about when I say fixing because of wind is that if you've got a clamp here on top of this, and a high gust of wind comes and your panel's tilted at 10 degrees, the wind's going to want to pick up the panel and make it fly away, obviously. So in this case, the only thing that's really stopping it is that clamp. And that clamp is being held by this roof sheet, and that roof sheet is actually only staying on top of the roof because of a little bit of friction between metal and metal there. There is a small little lip on the top of the clips here, but realistically, the only thing that's holding this sheet to the roof, no matter how great the roof is a bit of friction between these 2 pieces of metal here. And you can see that that's something that it's quite scary in the scheme of installations, because you might think, it's a brand new structure, but then they put this, Fielder's King Clip on top. And Fielders are a great company, and they've got great products as well. I would say it's mainly builders that want the cheapest or whatever it is. But here you've got Fielder's Hick Clip, where they've done the same kind of structure. They've penetrated the clips into the roof, but in this case, they've wrapped around their internal clips into the roof sheet on both directions. They have 2 hooks that go down, and the clip on one side is connected to the clip on the other side. It's quite a rigid system, far greater than this Fielder's 700. And you can see the capacity difference. The Hick Clip is closer to the high strength 700. It's like 2 kilonewtons plus, whereas the Fielder's is only 0.8, which is probably a third or half of the capacity of the Hick Clip. So it makes a big difference. And the reason I bring this up to the sales team is when you look at a roof and you see it's got screw lines on the, you can sometimes see screw lines on when you're looking at the aerial view on Nearmap or on Google, then you should know, hey, fixing shouldn't be a problem. Yeah, fixing shouldn't be a major concern. But if you go in there and you see, a really old type of, non-penetrative concealed roof sheet, then you say, oh, look, I might need to bring that up with the client, because at this point, we don't know what it is, but it's got to be one of the considerations they've got to know. So we don't know much about your structure. We don't know much about your roof sheet type, but engineers will look after it. But I just wanted to have that conversation now and talk about the steps that we need to go through in case it comes to help mitigate the situation later on. And I assure you, every client will be so much more grateful when you have that conversation early. Main considerations I wanted to point out are penetration is no concern. So when you're looking at screws that penetrate through the roof sheet and go into the structure itself, the capacity of that screw is determined by the depth of its penetration into the timber or the steel. I should say if it's steel, it's dependent by the thickness of that steel that it's penetrating to. But if it's timber, it's on the depth of that. And you can see, so the capacity of the screw is far greater. It probably starts around 2 kilonewtons and it goes all the way up to 2.8 or so. And so it can be the strongest form of fixing connection. Roof sheet clips are commonly the weakest part of the system. That's one thing that you should always know, that if you are looking at clips, the most critical factor usually does come to be that little section where your clamp is connected to the roof. And now, the whole reason we've dedicated a whole 45-minute presentation next Friday on this is because we're going to go through what manufacturers have done to kind of eliminate these concerns and try and further understand how clamps work to eliminate the potential risks of them not working on site or something going wrong. One of the negatives of our industry is that, of the engineering part, is that if we have a 700 roof sheet and we can't define which one it is, then a lot of the times we have to assume worst case, which is fielders, right? To say that, hey, look, we know it's 700, but there's 10 manufacturers of this 700 style roof sheet. We don't know which one it is. The client doesn't know what type of roof it is. So what do? The only option that we have is to assume, hey, it could be fielders. And if it is fielders and we say it's not, that's really dangerous for you and for us. So we have to assume that it's fielders. So getting any kind of information, whether it's lifting up a sheet and taking photos of clips or any type of additional information, can help you with your assessment results. And lastly, if you don't know what it is and you need an extra, it's a 700 roof sheet or it's even an unknown roof sheet, you've never seen it before, then we actually come out and do physical testing on site. The reason I'm bringing up the sales team is that obviously that adds cost and unknowns that you didn't know about before. So if you see that it's a concealed roof sheet and you've got it ordered out, like taking photos, having that conversation as early as possible will help mitigate that concern of your client later on. So what do we do for sales teams? So we've created little spreadsheets, we've created little systems. I've had multiple training sessions going through similar stuff to this, if not the exact same thing, saying that, we really want to feel as much as possible that we're a part of your team, right? We don't want you to think, like a lot of salespeople think that engineers are, at times, reducing their size, reducing their sale. I understand it from my sales experience. If I closed something that took me 2 months to close and then someone came up and cut up half of it, I would be, quite annoyed myself. But understand that we're doing everything we can. Our first outlook on everything is, let's make the maximum amount of panels get on this roof. That's what every engineer is thinking. But the limit is the strength of the building, right? Unfortunately, that's the governing thing that holds us back is the standards and the assessments and everything we have to do to follow them things to ensure that you can get your structural certification so you can go on with the installation. But we're doing everything on our end, whether we do, change the direction of installation or, put more clamps, or we're doing everything we can. We're doing extra over and beyond budget checks to make sure your sale goes through. A lot of the times it's just not possible because the building is just not possible. But the truth is that, it's been a long process for us to kind of learn different ways to try and make things work more. And I believe we're getting better and better every day. So I just want to say, on top of that, direct support, right? I'll give you my number at the end of this presentation, my email as well. I can be a direct support to any of you guys. If you have any questions, you guys are usually quite tech savvy. Just share your screen, get on a chat, share your screen. Hey, Sana, I've got this or this. Do you think I should be having these conversations early? Do you think there's going to be concerns? Absolutely have these conversations earlier. Now, this is the current sales cycle that most companies have. And I'm not going to go into the details of the actual internal sales. I'm sure these are a lot more complex and detailed than I'm making it out to be. The main reason I want to bring this up is because of where we sit in the process, right? So you have your warm leads and you make it into a sale, you generate a preliminary package, you give that preliminary package to a project manager. Project manager reviews all the works and gives it to the structural engineers. Now, although that is working and it definitely is being successful for all your companies, what we want to kind of move towards for most companies is the next step, which is bringing us in earlier into the cycle, right? By flipping things just slightly, it doesn't actually mean a full costed blown out assessment, because you still need to go through your preliminary package deals and everything as well. But working with the project managers, although they're great individuals, can sometimes be too late and quite frustrating for them. We need to be brought on earlier so that they understand what their limitations are before they pick up the job and start worrying about installing. The truth is, once they get the project and they're trying to make it work, the last thing that they need is to hear about them having to find new areas and them having to find different considerations to make it work, because we came in right at the end when they were ready to install and said, your corner zones have got too much wind pressure. Right, so the little stuff we do at this stage are things like that spreadsheet that we put, giving you information about where your exclusion zones are, then saying, hey, Sana, can you do a preliminary assessment on this big project? When the project comes through, it's going to be yours, but can you just give me a quick output on what you think it is? Like, if there's anything we can do, whether it's conversation-based, whether it's mathematic assessment-based, whatever it is, we're happy to help, especially for some of your big projects going to have a lot of complexities. The earlier we get involved, the better it is. And we don't see it as we see it as a place of building this relationship to ensure that you guys are happy throughout the whole process. We get a lot of calls from your PMs, but I can tell you now, I rarely get calls from your sales guys. There are a few sales guys that do call me, but we rarely get calls, and it's a concern because you can be taking advantage of our support as much as the PMs are as well. Project considerations, and I'm going to be talking about these in the view of the salesperson. So we did it in the view of a project manager, but also talking about costing and budgeting from a sales point of view, how much you should allow for engineering when certain things come up. So building structures. So we went through this last week. This is what I was talking about when we're talking about new structures. This is an example of a brand new structure when we got involved in the project. And it looks from looking at it, it looks like it's got a ridge line down the middle, quite straightforward and symmetrical on both sides. You've got these kind of openings on either side. So it looks like it's going to be more or less the same structure on both sides. So if we're pricing this, we initially think it's going to be one set of purlins and rafters that we have to assess. This is the upper structure that we were talking about before. But it might need more because it's new. And the reason I say because it's new is because new structures, they have a lot more pressure in the design process. This is an example, not of the slide before, but just an example of new buildings in general. As you now understand, the corner zones and the edge zones have more wind force, right? So these days, engineers are kind of pressured by builders to reduce the amount of steel that's brought on site and installed on site. The reason they do that is because of cost. Steel is priced at its weight, and changing purlins from one part of the building to the other part of the building may save them $20,000, $30,000, $40,000. In the past, we didn't have these complex models and algorithms and whatever it is to come up and generate these exact purlins for that area. So what we used to do is we used to design one set of purlins and rafters and then apply it throughout. You design the most critical and then apply it throughout, which means that the internal part's a lot stronger than the edge parts. But in new buildings, you might have 3 or 4 different types, one in the center here, one in the edge here, another one in the edge here, another one in this intermediate edge kind of area here. And they all span at different lengths, and they're spaced at different lengths. And although that might mean not much to you, that to us means 10 times the amount of work, but for the same one building, right? We could put a megawatt on an older style warehouse, like 90s built warehouse, for the assessment of one roof assessment, right? Which is about $700-800. But then we get another building that's quite new, and the same kind of megawatt is now at $3,000-4,000, 3 times the cost. So the reason I bring this up is new buildings, although they are great, usually they are quite great in their capacity, they have issues with having multiple types of purlins and spans and different things like that. And especially with shopping centers as well, we see this with shopping centers a lot. We're kind of dealing with one right now where they've just got a ridiculous number of multiple types of purlins, the spans, and it just obviously blows the budget, because when you look at it initially, you say, yeah, that should be one structure, right? In a normal world, that should be roughly one structure, and you can kind of price according to that. But as soon as you get new buildings, you should say, hey, Sana, I've got a new building. What do you think? What do you think would be the maximum? Before we even start talking to the client, what do you reckon? Oh, look, I reckon there's something like this. Will probably be 2 or 3 purlins at most, but we can get it done in 2. Now you're having that conversation. After 3 times doing that phone call, I guarantee you'll know from that point, and you won't even need phone calls anymore. Moving on to other considerations is multi-site projects. Multi-site projects in regards to costing, understanding now that obviously this building is going to be different to this building, and this building is going to be different to this building. So if you have a megawatt on a big roof, it can cost you as little as $800. But if you have 200 kilowatts or 300 kilowatts on 10 different buildings, then the budget requirements are obviously significantly higher because each of these buildings are reacting differently. Each of them have different spans and spacings, and the purlins are different sizes, rafters are different sizes. So when someone asks me to do a proposal for something like this, and I give them a quote of, let's say, 6,000 or 7,000, and they question why, it's because, you know, I need to assess this building separately to the way I assess this building. And when I go on an inspection, I might need an EWP to get up on these buildings because they're 2 stories high and I can't get a ladder on there. Or there's so many considerations you've got to take when doing multi-site projects. I would definitely be asking you guys not to give your clients a fixed cost or for something like this. I don't know if it's even a possibility for you guys, but any kind of way of getting us involved earlier in this and saying, hey, what's a preliminary price for this? Happy to do it. Even if it's, hey, son, I haven't even or just looked at the project, but what do you reckon something like this would cost? Over the phone, I can give you just a ballpark, you know, plus or minus, to give you some kind of understanding of what you're looking at prior to getting out on site. The biggest issue I found with working with any solar company is the unknowns, and the unknowns are usually costs. So if we try and eliminate the unknowns, you overall reduce your costs. I'll go into a bit more of that in the next, in 2 slides. In the next slide now. But in this case, and this is the biggest one I want the sales team to take out on is excuse me, is loading up the north side of the roof. Now, God bless you guys, you love your north face, and it's really great for output as well. So I understand that, you know, there's good reason for what you do, but we have to understand why there can be a problem, right? So here you have an example of someone's, you know, asked me to load up this north side of the roof. And although, you know, it's a great output in energy, what you have to understand is by the integrity of a building is effectively in its portal shape. The image I showed you before where it had 2 columns and the rafters, that is almost like a fixed and rigid system. Now, the second you want to load up one side of that, you're going to get bending in that triangle almost. And then you start losing the integrity of that triangle strength. Right. So what we want to do now is understand that if we're going to be putting a certain amount of load, let's say in this case it's left, but let's just say it was down like this, you get the same kind of bend going down like this. And then the other side will be having upward pressure. And then all these forces are going to be going down to the rafters, down the columns and into the foundation. Now, although it may be okay, we're not saying that it won't work. We're saying that that building was not designed to have one side heavily loaded. It was designed for uniformly distributed loads over both sides of the roof and with no additional, you know, major point loads in one area. In this case, you're putting a uniform distributed load, but it's all on the northern side of the roof. So you're really reducing your integrity of structure. What can happen is you get major deflection on your purlins, firstly, themselves, and then anything that's off the purlins. So you've got pipe work, you've got false ceilings. There's a lot of stuff that you could have there that could start cracking. You know, your emergency fire systems will start cracking, and they start spraying water around. And it might not happen now, but it could happen in, you know, 3 years' time when a big gust of wind comes and it's major pressure, the wind's pressured onto the north side, and you've loaded that side with it. It's already towards its deflection limit, and now it's gone over. So the way to save this from happening is to, when you're putting a certain amount of panels on this side, it might sound silly, but chuck some on this side. Right? If you put it as a ratio of like, you know, 70 to 30 or something, just something, give it some counteracting weight so that they both become uniformly loaded. Now, it's not going to be perfectly uniform, but it's definitely going to be a lot better than what you're doing here. If you're going to, you know, take every, you know, third row out and chuck it on reverse tilt over here, sure, your energy output's not going to be as good as if it's all on your north face, but you're going to be a lot more certain that there's not going to be any huge structural problems with your building. So, reiterating the point, I understand you're looking at it from a sales point of view, looking at energy output, but understand that greater than energy of output is the safety of that building, the people inside, and everything like that as well. So you need to start taking these considerations and say, hey, I know now that guy on that presentation didn't remember much of what he said, but that north face can't be too overloaded. I could have put some on the south face now as well. In regards to the structure assessment, it doesn't cost you any difference because when that rafter and purlin is going to be the same as that rafter and that purlin. So it's going to be more or less the same thing. Now, if you're tilting it and flushing it, then it becomes a different conversation. But in general, if you're just putting flush on both sides, it doesn't cost you any different, but it's really just making sure that the building is now safe. Which is really a huge point that I want you guys to take out of this. Lastly, costing for inspections and just for assessments in general. This is a really good example of one that is a lack of information. And again, lack of information costs a lot of money. Um, we see it happen every single day. But in this case, it was a really good case because initially, I was asked to price this, and the salesperson told me, Santa, it's really easy. All the buildings are the exact same. I don't have drawings or anything, but if you could just, inspect one of these buildings, um, all the rest have been built by the same builder by the same time. And I'm in my head, great, that's fantastic. If that is the case, that's fantastic, because if I design this one, which is probably the most critical, and these are the exact same and they're going to be less critical, then we could probably apply throughout, right? And we could reduce cost on the assessment because they're the exact same. We don't need to assess it again. There are some factors like wind directions, but we can do quick checks on that. We don't have to charge the full amount of, certifying 5 roof areas. But when we actually got on site and the engineer did the right thing by checking the different sections of the different buildings, they realized that the buildings were used in such different ways, right? So you had, a section in this building that was used as a big fridge that had massive fridge ceiling tiles. Then you had a building here that had a massive fan or something like that. And you had another building here that had, a walkable ceiling or whatever it was. These buildings are now used in different ways. There's different loads on top of onto the roof structure, and maybe not on top of, but even on the underside of the roof structure. And now they're very different assessments. Now each one is a very different assessment. So when we priced this initially, and the salesperson told me what they told me, good on them. They're just telling me, they're just regurgitating the information the client's given them, right? So it's not, they haven't done anything wrong. They just didn't understand that initially quoted at, let's say 1,000, now it's quoted at more than 10,000. Why? Because we have to inspect 10, 11 spots. We have to assess all of these 10, 11 spots quite differently because they all have different types of loads. So this is not one for it's more for the PMs to definitely bring up things that they see have been attached on buildings. But from the sales guys as well, don't take everything you hear from your clients to fact. I think you need to definitely allow conversations like, that's fine, that sounds great, I'll just need to get my guys to go out and check that. Whether it be your internal guys in your company or our engineers, us as engineers or any of your engineers to go out there and see it for themselves, it's a definite requirement for you guys to ensure that the safety is still met. And lastly, I want to make a point about if there is big fans and if there is, these ceiling tiles and fridge tiles, that doesn't mean it's not going to work. It just means that we just hope that the building's been designed for them type of loads. So if there's massive, massive fans that we see in Queensland a lot of them times when the design engineer initially designed the building, he took them massive fans into account. So now the additional weight of 15 kilogram panels isn't going to blow the budget. You know what I mean? It's not going to push it over the deflection limits of the building. So it still can be more than fine, but we just need to know now, and we need to understand why it's coming up like that. All right. In summary, guys, thank you so much for your time so far. In summary, we just talked about how do you close and introducing that conversation a bit earlier, saying to yourself, hey, there's a few warning signs that guy told me about on that presentation. I need to take them into account on this one because, it's quite a high pitched roof, and I shouldn't be putting stuff on the corners. So now introducing that into your sales flow, your conversations, and then into your close as well. A lot of this stuff is pending structurals. We need to get a structural expert to look at it. I have, a good fair understanding of how it works, but I need to get a structural team to look at it to try and eliminate some of the problems that I'm foreseeing, which is the spans being too big or the building being quite high or whatever it is. And the critical factors that we talked about were the wind and weight. Wind is being one of the most critical factors, and then roof sheets being something that can be a problem with. And the warning signs that we said, let's go through them one more time together. It's the age of the building, whether it's brand new or quite old. Both have their positive advantages and disadvantages. The height of the building, obviously the wind pressure depends on its height. And the other factors I had were, it's going over the top of my head now. We'll come back to that. And lastly, we got the sales flow. Introduce us as early as you guys can. If we can give you any spreadsheets or tools or anything like that, let us know, and we can give you this support to then help you better PB design initially, so that your PMs your project managers don't get a problem right at the end when they say, hey mate, we can't use all your corner zones. They understand now why that's a possibility. And we went through some project examples. it'll happen. More of these cases will happen. I hope none of these cases happen to you. But the big thing I want to point out in the project examples is unknowns have costs, and I think I'll go through it in the commonly asked questions as well. So I'm going to take the next slide. These are questions that I commonly get asked by sales guys. What I want you to do is take this time to write any questions. I can see that I have one, I believe, right now. I have more, but Martin's been working in the background answering your questions for me. But if there is any additional questions, feel free to leave them in the comments now. We'll give a minute or so to go through them towards the end as well. So in regards to the common asked questions is around our pricing. So when you're pricing our pricing as a sales team and saying, hey, we can allow this much for engineering, how do you go about that price? I'm going to be showing you guys this presentation link, and you can click on the hyperlink directly, but it's all on our website. We have more or less fixed price services for per roof area. So if you look at a building and you say, hey, that's going to be, it's an L-shaped building and one's wider than the other one, then that's going to be more or less 2 roofs, and you can go on the website and see exactly how much that 2 roofs will cost you. And then there's different types of services, whether it be, checking your array frame after 20 meters of height, whether it be pallet loads, like that you're going to be installing with cranes and pallets. How much is that going to cost you? Same kind of thing. It's all broken down on the website. It's all quite straightforward. Gantco.com.au/solar-engineering, and then go through to the roof mount section if that's what you're looking for. Second question is, what is the biggest sign of budget blowouts and underestimating projects? As I mentioned a few times already, and the reason I say this is it's not having enough information. Having little or incorrect information is usually the biggest cause of the budget blowing out, not only for your installation, but also for our assessment. Providing structural drawings as early as possible is critical, especially even pre-quoting, because then we can give you an accurate response. I had a conversation yesterday with a gentleman who gave me structural drawings, and it was great, and we had all the information we needed, but the truth was that the building was horrible. So, but at least then, before even starting the project, I can tell him, look, out of absolute respect to you, this is a really crazy building, and it's going to cost us a lot to assess and to fix. So what do you want us to do about it? And then we had that conversation, and it went a lot more smoother than us getting out on site and doing 30+ inspections without realizing that costs are adding up and things are blowing out of proportion. So structural drawings are definitely most critical, and please, if you have access to them, don't listen to people when they say they want to install in a hospital but they don't have structural drawings. I assure you there's been 15 companies that have looked at them structural drawings and councils and people and whatever it is. So they do have them. It might take a little bit extra time to get that information. Lastly, how long does it take to get a quote and complete a project? Which is very common in regards to when you're looking at time schedules. For a preliminary kind of chat, give me a call whenever you want, and that can be sorted in that way. But for an actual project, it depends on the size of the project. In general, for a simple one warehouse design, it takes, on that day, if not the day after, for a proposal to give you a price on how much it'll be. And then the assessment itself is 2 to 4 business days. And it really does depend on, our projects go through 3 hands. So the design engineer that does it, and then there's a quality assurance process that goes through a senior and a principal engineer to check and sign off the works. That process is the delay in time, really. The work itself for a single warehouse usually takes about a day. But it's getting it through the hands that can take a bit longer, and depending on the schedule and how busy we are as well. And certain times of the year it's a lot busier, and it can take a lot more than that. Guys, I want to take this moment to firstly thank you for your time today, and thank you for joining. We have a much better participation than I expected, so I'm really grateful for your time today. I hope you have taken a bunch out of this, and I hope that we can continue having these types of conversations with both myself and with clients. If you're more interested in stuff like this, feel free to give me a direct email or call or anything you need to help you go through it in more detail and to help you understand a bit more about I would love to know more about your sales cycle, and you can let me know more about the concerns and questions you've had maybe in previous jobs that you've worked with Gantco directly. And if you haven't worked with Gantco, how we can look at doing that as well. Now, let's quickly go through I've only got one question, which is great. All right, I've got a question from Andre. Andre, if a system is designed using pre-certified fixings, e.g. Hobbichi Alfie, installed according to the certificate, is there a need for a structural assessment? That's a really good question. So general certificates, although they are great for their purpose, if you remember that first slide, I broke it down into three assessments that we do. We do a site-specific array frame check, which is effectively a 10%. It's not an array frame check a full service. But if it's within the parameters of the certificate, we do a quick check on that. It's worth about 10% of the assessment, right? In that case, your fixing, according to your general certificate, would be fine in that array frame. The array frame system would be fine. Now, the fixing is the 40%. And that fixing says, according to a certain wind region, according to a certain height, according to a certain something, use the general certificate to ensure that this L feet has been certified. And that is correct. So from that 50%, you're all good. You understand that your L feet have the capacity, and you understand that your array frame is certified for that height, that wind region, that terrain category, and so on and so forth. But what you haven't got at all in them general certificates is the whole other 50% of it, which is the structure itself, right? The structure itself has many other concerns and questions around that. And if you're installing based on general certificates, that's got no tie to a structure. It's just telling you that the array frame that you're using isn't going to fall apart on that roof or dislodge on that roof, which is great, but it's not answering the problem that we find with general certificates. It's not answering the problem of the building. It's just answering the problem of that little L feet. In saying that, another point I'll make is that the general certificates are quite broad in the sense that it's certified for up to 20 meters of height, right? And we've done these ourselves, so I'm not saying it's a bad thing. We have to do it. You know, you want to get a product into Australia, you want to make sure it's certified for Australian use. You have to get a general certificate or some kind of certificate stating that it is suitable according to our standard, and so that's why we do it. But when you have a 2-story building, which is only 3 meters tall, and you're using the spacings from the general certificate, then you're using spacings that are applicable for something up to 10 meters high. So if you were to go again site-specific assessment, you may get a decrease in rails, a decrease in fixings, feet, or you might find other things will come up that you didn't know about that were going to be concerned, but because you thought you had the general certificate, you were going to go ahead and do it just based on that. General certificates are great for their purpose of certifying, making sure that the products we use in Australia are certified and done correctly. But in general, a site-specific is always definitely more catered for. Now, the other questions that I've seen Martin has answered, a lot of them were around edge zones and stuff like that. I hope the rest of the presentation answered that. If it hasn't, my email's at the bottom. It's just my first name, sana@gantco.com.au. Feel free to shoot me an email, and on my reply, you have all my phone contact details and everything like that. Feel free to give me a call after that point. There's been some other questions about roof sheeting, some other stuff. I can see the names and I know who they are. I'll definitely reach out to them and talk to them directly about that. If there's anything else you guys need, again, guys, do not hesitate. We're here to support you. We like to think that we're all one team, and we aim to all be one team. So definitely reach out, and we'll definitely be able to help you with your sales full process. I really appreciate your time again. I don't want to take any more of your time. We'll hopefully see you guys on Wednesday for the site audit or the site inspections, and definitely on Friday for the unknowns about roof sheets. Guys, thank you again. Enjoy the rest of your day, and definitely enjoy your weekend. Cheers, guys. Bye.